Okay, we are going to start our probability and statistics chapter with talking about sampling, random sampling. All right, so first of all, let's just define, we'll also talk about different types of studies. We'll talk about bias in questions and those kinds of things, and inference as well. But let's start with just defining sampling. So first of all, you would sample if you wanted to learn something about what we call population. And this is all the things that you're trying to study. Now, sometimes it's people, so sometimes you want to actually learn something about a population of people, but it could be other things, right? It could be your population might be like white pines in Michigan or something like that. So it's not just people, it's just anything that you want to study, any group of objects you want to study. And a sample is a subset of the population, a representative subset. So you try to make your sample as representative, in other words, matching the characteristics of your population as possible, as best as possible. So if we want to know something about the white pine trees in Michigan, we can't look at every single white pine in Michigan. That wouldn't be practical nor useful. But what we can do is we can get a sample of white pines. For it to be representative, it would have to be something, we would probably want to take white pines of different heights for our sample and at different areas of different parts of Michigan, those kinds of things, depending on what we're trying to study. Okay, so a sample is a subset of the population. Hopefully, if we do the study right, it's representative. There are three different types of studies that we're going to look at today. And the first one is a survey, and you guys are probably all familiar with surveys. It's just when you collect data or information from a group. Sometimes that's literally the name of what the questionnaire is a survey. An experiment is when you're studying something and you divide the objects into two groups. One is an experimental group where you do something or you take something away or you add something to that group to see if it has an effect. The other group is a control group where you don't do anything to it. So if you're trying to test a drug's effectiveness, for example, you might give the drug to a group of people and not give the drug to another group and see how they compare in terms of whether the drug helps or hurts or doesn't do anything. Sometimes you give the control group a placebo, which is a drug that intentionally doesn't do anything to, kind of negate the placebo effect. But anyway, the last type of study we're going to look at is called an observational study. And this is just where members of the sample are measured or observed. Okay, so in this one, the big difference between an observational study and an experiment, it's easy to confuse the two, is that there is no control group. It's an observational study. Okay, so continuing on here. All right, an advertising company, let's do the first example. An advertising company in Cleveland wants to test a new logo design to be put on billboards around the city. They randomly select 20 participants and watch them discuss the logo. Is this a survey, an experiment, or an observational study? You might think about what that is in your head for a second. All right, this is an observational study. What they've done is they've picked 20 people, and they're not really surveying them, but they're just showing the billboards, and this is called a focus group, and they're just observing what they say. So this is an observational study. All right, what is a sample and what is the population? Well, the sample is the 20 participants. We'll say 20 people. Okay, and then the population is the city of Cleveland. Or I guess you might say, if we had more space, we'd write city of Cleveland. We'd write that it was the people in the city of Cleveland, or the population of the city of Cleveland. So that's the population of the sample there. Number two, you want to find out if a new reading program can increase reading comprehension. What is the best type of study to determine this? Again, you might think about this for a second. If you want to test if a reading program is going to work, or any program really, then the best thing to do is an experiment where you might take one classroom and you give them the reading program, and you might take another classroom and not give them the reading program and see which one does better. If the one in the reading program group does better than the non-reading program, you might make an inference that it is a good program to implement. But of course, you'd want to do this multiple times to make sure that your first experiment wasn't just a fluke That's called replication, replicating your results. All right, random samples. Randomness is actually much harder than what you might think, but there are a few ways that you can get a random sample. Pulling names out of a hat is one obvious way or simple way to do it. You can use a random number generator. And basically, you can use any way where you can make sure that the participants are chosen randomly, where bias can't seep into the selection of the group. Okay, so let's look at this example here. Is the following in number 3 a random sample? Hannah is trying to determine how stressed students are in school, how stressed students in the school are right before test fest. She asked all her friends during lunch and her Algebra 2 classmates. Okay, so this is not a random sample because Hannah did not, the population that she's trying to understand is everyone in the school, all right, and her sample is not representative. So for instance, she picked only her friends, which is not going to be, representative across all the students in the school. And then also, her Algebra 2 classmates are probably going to be of a particular age, right? So she's probably leaving out freshmen. She may be leaving out seniors. It's just that her sample just doesn't represent the school. And for it to be representative, you'd want students from across different demographics, as well as different ages and different. You would just want a sample that looks more like the entire school. So this is not random. Okay, talking about bias. Bias questions are questions that are asked in a way that that maybe they address more than one issue. They might use emotionally charged language and intended to get the person to answer a certain way. Sometimes these can all be used at the same time, so to encourage a certain response. Those are types of biased questions. Unbiased questions are questions without the biased characteristics, right? So if you're just asking for objective facts, those kinds of things are much less likely to be biased. So let's go through these examples here so you can kind of get an idea of what a biased question looks like. 4A here is, do you agree that the lengthy construction of the parking lot would be a waste of money? So this is emotionally charged language. Do you agree that the lengthy construction of the parking garage would be a waste of money? You're more likely to, conclude it's a waste of money with the way that it's phrased here. If you want to know something about, how people view the construction parking garage, you can probably ask this in a way that is less emotionally charged, all right? So this would be biased. How many cars does your family own? It's unbiased. Right? Just an objective fact. How many count? Right? Are you concerned that CFL light bulbs may contain deadly materials? Well, how could you not be concerned about that? What you really want to know is about how people's perception of the safety is of CFL light bulbs. So you could ask something more like that. Are you concerned about the safety of CFL light bulbs? Right? But by putting deadly materials in there, you're clearly trying to make the person that's answering it reach a particular conclusion. So this is bias. And sometimes in class we go back and forth on biased and unbiased questions from the assignment. So, on the quiz and the test, we will not try to trick you or anything. So, we'll try to make it clear whether they're biased or not. Last thing here, inferences. A conclusion reached on the basis of evidence and reasoning. To infer something just means that you've taken the evidence in and you've made a judgment and you're going to draw a conclusion based on it, okay? So in this example, let's look at this example here with Mia. Mia surveyed a random sample of 120 of the 843 employees at her workplace. So her population is employees at her workplace. She's got a sample of 120 of them. Let's assume that she found them randomly. She found that 87 of her employees eat breakfast before work. Okay, so 87 out of the 120 that she sampled eat before they come to work. What is the most reasonable inference about the number of employees that eat breakfast before work? In other words, what we're trying to figure out here is if 87 out of 120 of the sample ate breakfast before work, how many of all of the employees of 843 could we conclude probably eat breakfast before coming to work? Okay, so to figure this out, we need to know what percentage of the sample ate breakfast before work. So this will be, to figure that out, we will take 87 divided by 120. And let's see what we get. And I said percentage. We really do just want the decimal though. So we'll take 87 divided by 120. Okay, so it looks like 72.5%. Okay, so this is 0.725. So we can conclude that about 72.5% of the employees are going to eat breakfast before coming to work. So then if we want to know the inference, then what we'll do is take that 0.725 times it by 843, and that will tell us approximately how many employees ate breakfast before coming to work. So we'll take 0.725 times 843, and so about 611 employees. So you want to round to the nearest person. So about 611 employees. Right? And that's it. So there's several examples like that in the textbook. As I was going through the assignment, I noticed that. So, but that's the process, right? What is the percentage of people from the sample, and then what does that mean for the entire population? That's the inference piece is right here. Okay, but that inference is made based on the sample. That pretty much is it for section 8.1.